Welcome to this GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on the architecture of the CPU. The CPU is the central processing unit. The role of the CPU is to process instructions by running the fetch, decode, execute cycle. The CPU is often thought of as being the brain of the computer. The CPU is made up of a number of special components as seen below. These are the ones that you need to be aware of for the exam. The arithmetic logic unit. This handles all mathematical operations and comparisons. It also handles logical operators such as and, or, and not. The control unit. This decodes instructions and controls and coordinates the movement of data around the CPU based on the tick of the clock. The cache. This is very fast but small memory locations for storing recently and frequently used instructions. And registers. These are super fast storage locations located on the CPU for storing instructions and data as they are processed. As well as the general purpose registers that store instructions and data as the program executes, the CPU also contains some special registers that have specific purposes. The four you need to know about for the exam are shown below. The program counter stores the address of the next instruction to be fetched and executed. The memory address register temporarily holds the address of the next instruction or piece of data to be fetched so that the computer knows where to fetch it from. The memory data register temporarily holds the actual instruction or piece of data that has just been fetched until it's needed. The accumulator holds values that are directly loaded into it, as well as the results of calculations made in the arithmetic logic unit. At the fetch stage of the fetch, decode, execute cycle, the program counter holds the address of the next instruction. This address is transferred to the memory address register. At this point, the program counter is incremented so it points to the next instruction to be fetched and executed. Next, the instruction at the address specified by the memory address register is returned from RAM and placed in the memory data register. At the decode stage, the control unit decodes the instruction by comparing the binary instruction it received with its instruction set to work out what needs to be done. If the instruction requires some data to be fetched, such as the instruction add 105, the address of the data that needs to be fetched will be passed to the memory address register. If there is extra data required, when it is fetched from the address in memory address register, it will be returned to the memory data register. At the execute stage, the instruction is carried out. If we return to our example of the instruction add 105, this would add the value of the data stored in register 105 to what is already in the accumulator. It is important for the exam that you are able to specify whether a certain register holds data or an address. So the table below summarizes this information. The program counter holds an address. The memory address register also holds an address. The memory data register holds either an instruction or data. The accumulator holds data. That brings us to the end of this video on the architecture of the CPU. Join me in the next video when I'll be looking at the factors that affect CPU performance. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.